Hello, this is Chris Kinberg from the International Foundation Group, and this is a further session on Python, and it's also part 3 of topic 3, and the video clip will actually be left on Moodle in topic 3, so have a look at it at some point. Right, first of all, we're going to have a look at two key concepts of branching and secondly iteration. So we'll make a start straight away without any delay. Last time we considered the syntax of Python and the semantics of Python, and roughly syntax corresponds to the well-formedness of the words of the language, and the semantics relates to the meaning of the expressions that we form and the statements that we form. And we looked at some very general considerations in topic 2. We had a look at the idea of scalar objects, and I think you should remind yourselves which examples of scalars that we looked at. And we also had a look at a variety of simple operations such as addition and multiplication and division, and how to express that in Python. And finally, we looked at how you can actually construct expressions from variables and values. And one expression can be formed from one or more expressions with suitable operations. So here we go. Today we're going to have a look at the string object type. We're going to have a look at branching and conditional statements. We're going to note Python's use of indentation, and then we're going to investigate Python's iteration and loop constructs. So which will then put us in quite a powerful position to write some interesting programs using iteration and loops. So here we go. So strings are made up or constructed from sequences of letters, special characters, spaces and digits, and the sequence is enclosed in quotation marks or single quotes. So here we are, we've got a string variable called hi, hi, and I'm assigning to that variable the string hello there. So notice it's a sequence of letters and a space, all enclosed with quotation marks. One operation that we can actually use on strings, which obviously is going to be quite useful, is that if you have two strings, for example, I've got a string called name, which is the string Anna, and I can form a new string by assigning the variable greet the string hi, which was, if you look above, is hello there, with name, the string name Anna. So in other words, I'm going to concatenate two strings, join them together, and the result is simply hello there Anna. Or if I wanted to, I could put in an extra space by assigning to the string variable greeting the string hi concatenated with a single space concatenated with name, the string name, which is Anna. And you can do some operations on the string as defined in Python documentation. So for example, we'll think about what else you can do with strings a bit later on. So I want you to say a few words about how to obtain inputs and outputs, because almost always you have to supply an input to a program and it typically will give some output. So we can actually display the output of a program by using the reserved word print. So you can use print to output values to the console, to your screen. The keyword is print. So have a look at this sequence of Python expressions. So first of all, assign 1 to x, the integer variable x. If you print x, you're going to print the value of x, and you will get 1 displayed on your console. On the other hand, you can set a string variable x underscore string the value of converting an integer x to a string. So if you then go on to print the sequence of strings and values, my favorite number is x, then followed by a period, and followed by x is assigned the value of x, you're going to get my favorite number is 1, full stop, and then x is equal to 1. X is equal to 1. On the other hand, if you can print the following in turn, so notice the format of the arguments, what's going to be printed out in the second statement does not involve commas. So I'm going to, first of all, in this line, I'm going to print out the string that my favorite number is, followed by x, comma, followed by a very simple string, full stop, followed by the string x equals, followed by the value of x. Here we're going to print out this string, and we're going to concatenate it with the string consisting of 1, and followed by a full stop, concatenated with the string x equals, concatenated with the actual string value of the string variable x underscore string. Try it out. I mean, get your Python interpreter working and run all these statements and tell me if you're surprised by any of the results. Secondly, we can get input by using the reserved word input. And what goes in between these inverted commas is anything you like. So you can tell the user what you want doing by way of input. So it prints whatever's in the quotation marks above, and the user is prompted, in other words, to type something in, then hits enter, and what he's or she has typed in is going to be bound to a particular variable. So here's an example. I've got a text variable, I guess, called text, and that's going to be assigned the result of inputting anything that you type in, and that's going to be have some kind of text value. It's going to be a string, in other words. So an input on its own returns a string, and you can assign that string to a string variable. So a very vague instruction, type anything you want, and if you now print 5 times whatever the value of text is, you probably get an error, right? Input gives you a string, so you must cast it, i.e. convert the type if working with numbers. So here we go. I'm going to do exactly the same thing. I'm going to request that the user type in a number, and this returns a number which is then going to be converted or cast into an integer value. And the result of converting it into an integer value can be assigned to an integer variable num. Okay, so num stands for the actual numerical value that you've actually typed in at the keyboard. It's been converted into an inch. You could have converted it to a float. If you'd entered, say, the number 3.4, you can convert that to a floating point number and then assign it to a floating point variable. If I now print 5 times the number, I do actually get a sensible answer. So if I've typed in the number 9, I'm going to get the result of 45 displayed on my console. So comparison operators work on all three types of integer, floating point numbers and strings. So I and j are going to be what follows variable names of any of the types of above. So having a look at the first line, maybe I is an integer and j is an integer, and my little program piece is, say, I is greater than j, and this is going to return either a true or a false. I mean, supposing I is 10 and 10 is greater than 11, it's going to return false because 10 is not greater than 11. Here I've got I is greater than or equal to j. So I could be a floating point number. It could be 3.4. It's equal to or greater than 3.2, which is true, so it'll return true. The value of this expression, when it's evaluated, is a Boolean, and the Boolean in the case I've just described is true. So I is strictly less than j could be a string. So I guess the string A is going to be less than the string consisting of the letter B. And we'll look at alphabetic orderings a bit later on, because it's quite useful to work with comparison operator on sequences of characters or strings. And here we've got I is less than or equal to j. So clearly 0 is less than or equal to 0. Okay? And we can actually test for equality by writing I and the use of the equal sign twice is equal to j. I is equal to j. So that returns a Boolean value. It's either true or false. So 10 is equal to 10 is certainly true. 10 is equal to 9 is false. So again, this operator returns a Boolean value. And finally, I is not equal to j, so it's a test for inequality. So 0 is not equal to 0 is false, and I is not equal to, sorry, and 10 is not equal to 10, sorry, start again, 10 is not equal to 10 is false, and 9 is not equal to 10 is true. So let's have a look at logic operations on Boolean values. So if A and B are variables which have Boolean values, then not A, the sentence, the expression not A, is actually going to be true if A is false, and false if A is true. So if A is true, not A is going to be false, obviously. And here we've got what's called conjunction, A and B. And this expression is true if both A and B are true. If one of A and B is false, then A and B is going to be false. If both A and B are true, then A and B indeed is true. Okay. Let's have a look at A or B, sometimes called disjunction, or is the disjunction operator. So A or B. This expression, A or B, is true if either or both are true. If A and B are both false, then A or B itself is false. If both A and B are true, then A or B again is true. And there is an operator that's called exclusive OR, which I haven't shown here, and it means that exactly one of A or B, not both, are true, and false in every other case. So what I've got here are in fact two truth tables. They're two tables. So have a look at this table as far as this is concerned. What I've got on the left hand side is all combinations of A and B's truth and falsity. So A could be true, B could be true, or A could be true and B could be false, or A could be false and B could be true. And finally, because there are four combinations of two truth values, right? Finally, A could be false and B could be false. So what I'm showing you here is the truth table for A and B. The truth of A and B is documented against the various combinations of true and false. So A true, B true, A and B is true. A true, B false, A and B is false. Or A false, B true, then A and B is false. And if both A and B are false, A and B certainly is false. No question about it. So have a look at the fourth column. What I'm actually setting out are the truth, what I call the truth values for A or B when we vary the truth or falsity of A and B. So have a look at this. If A is true, B is true, then A or B certainly is true. If A is true, B is false, then A or B is true. If A is false and B is true, then A or B is true. And the only time that A or B is false is when both A and B are false. Okay, so that's reasonably, should be reasonably clear, but I'm introducing a little bit of terminology here. I'm talking about the truth table. So if I were to give you a complicated expression, say A and not B, or C and not K, or not B and not C, which is quite relatively, compared to A and B, it's quite a complicated expression. You would be able to calculate the truth value of that expression for all combinations of the, I think it was 5 different variables. Okay, so it's a truth, it's called a truth function. The truth of complicated expressions, which involve Boolean components, it's a function of the truth values of the constituent parts. Truth function. So here's a little example of comparing two integer values in terms of their size. P set time is 15 and sleep time is 8 hours. Well, I don't know. P set time is 15 and sleep time, I don't know what these are supposed to represent, is 8. Then if you print sleep time is greater than P set time, what you're going to get on your console is false, because it's not true that P So, it's not true that sleep time is greater than p set time, is it? Having a look at the values of these two variables. And again, if a Boolean variable, okay, so Boolean variable is assigned the value of true, and a Boolean variable drink is assigned the value of false, then the Boolean variable both, which is assigned the value of drink and derive, is going to be assigned the value of false. So when you print out the value of both, you're going to print out false on the console. Right. Drink is false, and you're ANDing it with derive, which is true. And as we know from the truth table for AND, drink and derive is going to be false. So have a look at this little sketch drawing, and the three important things to note is that I've got some kind of vehicle here. To me it looks like a baby's pram or something, or a handbasket. I'm not sure what it is. Maybe it's a handbasket, and you've got to imagine a person pushing it. And the second thing is that we're in a maze of sorts. And thirdly, there's a little area here where there is free food to be found. So tell me how you could come up with a scheme or method for exploring this maze systematically in such a way that you're going to be guaranteed eventually to find the free food. I mean, there's no unique method for exploring this maze-like path, but one method might lead to this particular area in the maze fairly quickly. Right. So think about this. One method of propelling this robotic basket, empty basket, or whatever the vehicle is to follow these four rules. And you can investigate these four rules, and I think they're sufficient to navigate us around any particular maze. So if the right hand turning is clear, take the right hand. Otherwise, if the right turn is blocked, simply go forward. But if the right and the front turning is blocked, take a left. So if the right hand side is blocked, there's no entry, and going in the front is blocked, and the left is blocked, just reverse and go back. Backtrack, in other words. Right? So you can experimentally apply these rules. So the pushchair goes here and it finds a right turning, and takes this right turn, but the forward direction is blocked. There's no left, there's no right, so reverse. And since the right is blocked and there is a forward, one of the rules as we go up here. And I guess the way forward is blocked here, but we can turn right, so we go along here. So just play around with these four rules and tell me, perhaps next week, whether or not those rules are sufficient to navigate around the maze and to find the food. I mean, presumably we've got some sort of test of whether or not food's present and so on. But we're thinking about set of rules which, if applied, will take us to will solve our problem, solve our particular goal. And you can think of this as some kind of program, a set of instructions. Do this or do that, or do this or do that, depending on the circumstances. Well, we can implement these rules very easily if we know about if-then statements, if we understand branching. In other words, depending on a particular condition, we execute other instructions, and if the condition's false, we execute others. So let's have a look at these three variations of the if-then statement. And this is pure Python. So if for some condition, like the way ahead is blocked, colon, notice the colon after the condition. And secondly, notice the indentation of the first expression and the indentation to exactly the same extent for the second expression. I mean, the expression is simply, you can think of it as an action. So this is action 1, do that, then do action 2, and so on. And if the condition is not true, presumably, you skip doing expression 1 and expression 2, and you resume executing the program at this point. So it's at a level of indentation that matches the if here. So another a variant of the if-then statement is this. If the condition is true, then execute this expression, then execute that expression. Else, in other words, otherwise, if the condition is false, you execute this expression 1, then expression 2, and so on. So two slight variants. So make sure you understand the format and how you'd actually write these. And finally, I've got something called an elif statement. If the condition is true, if a particular condition is true, execute this expression, then execute that expression. Else if, so supposing this condition is false, else if this condition is true, execute that expression, then that expression. Else, so what I'm talking about here is if that condition is false and that condition is false, execute these expressions as this block of expressions. Okay, so that's reasonable. The only comment I've got is it's curious that instead of saying else if, as most other programming languages have it, there's this rather curious expression elif, but that's okay. Right. So condition has a truth value, and if the condition is true, then we evaluate or execute the expressions in the block following the condition. So indentation matters in Python, and it's how you bunch together blocks of code. So I'm going to give you an example of the elif, what I've called the elif statement, and I'm asking you, the user, to type in a floating point number, or at least a number anyway, and you're going to convert it to a floating point number and assign it to x. So just two numbers, x and y, both floating point numbers. The first test is this. If x equals y, notice the colon, execute the block of statements, the block of code that's equally indented after the start of the condition. So I've got, first of all, I print the two numbers are equal. And then secondly, I test whether or not y is not equal to 0. And if that's true, I can print x divided by y is, and give the value of dividing x by y. So if I typed in two numbers, 10.0 and 9.0, they're not equal, so I can print the result of dividing 10.0 by 9.0, print it out. Okay, else if. Okay, so one other possibility is that x is less than y. Elif. Else if this condition holds, print the value x is smaller. It is smaller. If x is less than y, then x is going to be the smaller number. Else, in every other case, there's only one other case, one other possibility. Here we've got the identity of two numbers. Here we've got one number being less than the other. And finally, in other words, y is greater than x. Sorry, y is... sorry, if x is less than y, okay, x is smaller, y is... I've got totally confused at this point with this simple statement. Three possibilities. X is the same as y, or x is less than y, or y is greater than x. Y is greater than x. It doesn't make sense. But anyway, think about that. I'm splitting possibilities up into three. If this condition is true, do that. Else, if that condition is true, do that. In every other case, simply print the number y is smaller. Y is smaller. So if x is not, x is less than, if it's not the case that x is less than y, and x isn't the same as y, then y has got to be the smaller of the two numbers. So thanks for listening to what I've had to say here. And run this little piece of program. I think I've given you a copy of the Python program to just put it into idle, IDLE, and execute it and see what results you get. And type in different numbers. So, okay, here I've just asking the question, what happens if you say x and use a single equality sign? You'll get a syntax error. Because a single equal sign is the sign for assignment, an assignment of a value. The only other thing I wanted to say is to talk about this condition. If y is not equal to 0, and I guess I'm saying only if y is not equal to 0, print x divided by. We've got to test to make sure that y is not equal to 0, because otherwise, if y is 0, x divided by y is going to probably cause the program to crash. I mean, unpredictable results, because the value of x divided by 0 is infinity, in case you didn't know. Okay, another little program which depends on if-then statements is testing. I mean, I won't analyse this in any depth. It's the Legend of Zelda in the Lost Woods. If you keep turning right at every junction, you're going to go back into the woods, and you're stuck in the woods. And the only way out of these magical woods is if you take a left-hand and then you'll exit. Okay, so what I now want to talk about very briefly are while loops. So this is what I really wanted to talk about. So it's while a particular condition holds, colon, notice the colon, notice the indentation here, same indentation for each of these expressions. So while the condition is true, I'm going to evaluate the expression, do the statement, do the action associated with expression. Okay? If condition is true, you do you execute all the expressions, and then after you've done that, you go back to the start of the while loop. So this construction is called the while loop. You go to the beginning of the loop, test the condition again, and if it's true, then again you repeat the execution of these expressions. You evaluate these expressions again, and then test the condition again. If this time it's false, you quit the loop. You come out and start executing the next instruction lying outside the while loop. Okay, so you repeat the execution of these expressions until condition is false. I mean, it might not become false, in which case your program won't terminate. So the Lost Forest example, which I've just shown you very briefly, I mean, all it does is it asks you to input a left or a right, and whilst n is right, if it's wait a minute, let me see, I've got to work this out. While you type in right, you're going to stay in the forest and you're lost. If you type in a left, you jump out of the loop and you're saved. Okay, control flow for two sorts of loop, while loops, and I'm going to introduce another loop called a for loop. So here's a little example using the while loop. First of all, you assign n to the, you assign 0 to the integer variable n, and you've got a while loop and there's a condition followed by a colon and two statements that will be executed again and again whilst this condition is true. So initially n is 0, 0 is less than 5, so you print the value of n out, which is 0, and then you increment n by 1. You add 1 to n. So n becomes 1, 1 is less than 5, so print out the number 1, increment n by 1, that becomes 2, 2 is certainly less than 5, print the value, I can't remember where I'm up to, print the value of n, which I think was 2, increment it to 3, 3 is less than 5, print 3, increment n, you now get 4, 4 is less than 5, print the value of n out, which is 4, increment it to 5, and you come out of the loop because 5 is not strictly less than 5. Okay, so there's a shortcut for using a loop, and it's using a for loop, and the for loop looks like this. So have a look at this. For n, the value of n in the range of 5, print 5. I mean, it's just 2 lines of code. These 2 lines of code do exactly the same as these 4 lines of code. Okay, so the question is, what does range 5 mean? It just means the collection of all values starting with 0 up to but not including 5. So for values of n starting with 0, then incrementing to 1, 2, 3, 4, print the value of n. So try it out. Try this little program out in Python, and if there's any surprises, then let me know. Okay. So just a little bit more on for loops. So the structure of a for loop looks like this. For some variable in the range, for some number, execute this expression and that expression. So the explanation of this, of its meaning, each time through the loop, variable takes a value. So first time the value starts at the smallest value in the range of the number, and the next time gets the previous value plus 1, so it's incremented by 1. So that's easy. So things get a little bit more complicated when you see the expression range, start, stop, step, and start represents the starting value in a range of numbers. And typically the default value of start is 0, and the default value of step is 1. And you have optionally you have a value where you need to stop, because stop represents the upper value that you're not allowed to reach. So you stop at a number or value of stop minus 1. Stop minus 1. So for example, have a look at this example. My sum is 0. So initially my sum is 0. For I in the range of 7, 10. So I guess 7 is the start value. So for I starting with value of 7 and ending but not exceeding 9, I suppose, increment my sum, my sum becomes the old value of my sum plus I. So my sum initially is 0, and my sum is the old value of my sum, which is 0, plus 7. So the value of my sum is 7 here. So print it out, display it on the terminal. And then increment I by 1, and you get 8. So this time you're going to add 7. Sorry, my sum is going to be the value of the old value of my sum, which is 7, and you now add 8. So the value is 15. Then the third time around the for loop, you increment, I'm going to lose track of my thoughts here, is 7, 8, 9. So the value of my sum is the old value of my sum, which was 15, and you add 9. That's 24. The value is 24. Then you display the value on the your VDU, your console, and then you increment I by 1, I think, to get 10. Right, but you've gone beyond. You're equal to the stop value, so you stop there. You stop with 9. You don't go as far as 10. It's like, this is the stop value, 10 minus 1. You stop at 10 minus 1, which is 9. So here the initial value of my sum is 0, and here I've got a start value of 5, a stop value of 11, and an increment value of 2. So my sum initially is 0. So my sum, first time around the loop, my sum is my sum plus 5. So my sum is currently 5. Print the value out, go to the top of the loop, and you're going to increment the value of I by 2. So it's 7. So my sum is the old value of my sum, which is 5 plus 7. You increment 5 by 2 to get 7. So the value is 12. And so on. I'll leave you to finish this or to run the program. So just to remind you, that's the start value. I becomes this value when you start executing the while loop. And you finish at a value 11 minus 1. But every time round the for loop, you're going to increment the value of I by 2. So try it out. And finally, I'm showing you a while loop inside another while loop. So while condition 1, while you're going at 100 miles an hour, and whilst it's safe to continue at that speed, do this. I mean, I don't know, just keep monitoring the road ahead. But then I've got a break statement here. What that means is that you finish executing anything in this while loop and you break out of that loop. And so if you come out of executing that loop, you're not going to execute that or that or that again, but you will execute the first statement in the outer while loop. So a break statement is just a convenient way of breaking out of a statement. I mean, there may be a need to do that. It might be convenient to stop the program running if a certain condition holds. Have a look at the program we've just been looking at, and let's just execute the line once. Let's execute the for loop just once. So initial value of I is 5. The value of my sum the first time around the loop is 0 plus I, whose value is 5 now. And check to see what the value of my sum is. Well, it is 5. If the value of my sum is 5, break out, stop executing it. You jump here and you'll print out my sum, and you'll see this is 5. What happens if you run this program? Can you find out for me, please? Little exercise, little practical exercise. Do it. I want you to do it. Okay. So very finally, you might want to compare for loops and while loops. So for a for loop, you know the total number of iterations through the loop. You have to state it in the first line of for something in the range of. You know, you're putting a limit on the values that the variable I is going to take. You could end execution early if the condition requires it. You could buy a break statement. It does use a counter. In the examples above, it used the variable I. You can rewrite a for loop using a while loop, so you can always translate a for loop into a while loop. Now, a while loop is quite interesting because it could have an unbounded number of iterations. I mean, the condition could be for 1 equals 1. In other words, forever execute the following statements. Can end iterations early if you want to, and a certain condition becomes true via a break statement. It does use a counter, but you must initialize the counter before you start executing the loop, and you've got to increment it inside the loop somewhere. So you've got to increment the counter value. You may not be able to rewrite a while loop using a for loop. And I wonder why. Why not? It's something to do with this here. Can you duplicate having an unbounded number of iterations inside a for loop? Just reflect on that a little bit and let me know what you think. Tell me next week. Okay, one thing I want you to do as a very short programming exercise is to execute the Python, I think it's a collection of programs, branch loops. So I think I've put that in Moodle. Okay, so thank you very much for listening. Hope it's been of some benefit and you're coming away with some further insight into the workings of Python programming. We're taking a fairly slow start, but the progress we're going to make in Python will accelerate, I assure you. Thank you very much.